from speed time graph. So from speed time graph, what we can do, we can calculate two things. Number one, we can calculate acceleration or deceleration from the graph, and the second thing we can calculate from speed time graph is the distance traveled by the object. So these are the two things which can be calculated from a speed time graph. One is acceleration and another one is acceleration or deceleration, another one is distance travel. So how to find acceleration or deceleration from speed time graph? So example, on x-axis you have time and on y-axis you have speed, which is in meter per second, and time is there, which is in second. Then the division on x-axis as the time interval, example 1, 2, 3, 4 and 5. And for speed, example 10, 20, 30, 40, 50. And this is a line which shows the change in speed. And the question is, find the acceleration of this object. So how we can find the acceleration? We know acceleration is a change in velocity, or we can say it is equals to final velocity minus initial velocity divided by time. So speed time graph, what is the final velocity here? When we work out the final velocity from the graph, so this is the final velocity. So final velocity, which is v. What is this initial velocity or starting velocity? This object is starting from speed 0, so initial velocity is equals to 0. So initial velocity is 0, final velocity is 30. And what about the time interval? The time interval between initial and final velocity according to the graph, that is equals to 4. So when we calculate the acceleration is a change in the velocity. So it will be 30 minus 0 divided by 4, or it will be equal to 30 divided by 4, which is 7.5 meter per second square. Is it clear how we can find the acceleration from speed time graph? So we will take the final velocity, that's called v. We'll take the starting velocity, that's called u, and the time interval between the initial and final velocity that we take. So change in the velocity, final minus initial, divide by time interval, that will give us the acceleration of an object. No, this is not revision. This is a new topic, Abdullah Sarfraz. From a speed time graph, how we can calculate acceleration, deceleration, and how we can calculate the distance. This is not the revision. Same way, if you have a graph and this is a line which is representing this change in the speed, So this is 0, 1, 2, 3, an example. Two, that's 3 and 4. So time is here in second and speed is in meter per second. So this was 10, 20, 30, 40, 50, 60, 70 and so on. And the question is, find the acceleration of this object. So how we can find the acceleration? We know acceleration is a change in the velocity divided by the time interval for this change. So what is the final velocity here? V means the final velocity and U means the starting velocity or initial. What is the final velocity from this graph? So how we can work out the final velocity? What we do? We will take the final point and draw a line on y-axis to get the final speed. So what is the final speed here? The final speed is equals to 50. This is a starting point. This is a starting speed. So what is the starting speed here? Starting speed is 20. And what about time interval? How much time it took to change the speed? So from 0 second to 3 second. So the time interval is equals to 3. So when we calculate the acceleration here, which is the change in the velocity divided by time, so acceleration will be 50 minus 20 divided by time interval is 3. So 50 minus 20 is 30 and 30 divided by 3, that's equal to 10 meter per second square. Is it clear now? The concept of acceleration, how we can work out acceleration from a speed time graph. Then if we want to calculate a distance travel, this is the first thing, we calculate acceleration. But sometime, one more thing, sometime the graph is not a straight line, it's a non-linear graph. So some questions, the graph is not a straight line. So how to get the acceleration for the graphs which are non-linear, which we call them as a non-linear graph. The term non-linear graph means like it's not a straight line, it is a curve. So how we can find the acceleration of a non-linear graph? So speed time graph is there. And there are numbers 1, 2, 3, and then 10, 20, 30, and so on. And this is how the graph appear. It's not a linear, it's a non-linear graph, means a curve. So when the graph is non-linear or the graph is curved, the graph line is curved, how you can work out the acceleration? So if I say find the acceleration, because if it is a curve, it means acceleration is continuously changing. And in this example, acceleration is decreasing as the slope is decreasing. So how we can find the acceleration? So we will draw a tangent. This is not a decelerating, the term decelerating graph, because it's a speed time graph. If it was a decelerating Abdullah Khan, then it should be, the speed should also decrease. It should be like this. But this is a speed time graph. When the slope is decreasing, it means the acceleration is decreasing. This is not the distance time graph. It's a speed time graph. So you have 10, 20, and 30 on for the speed on y-axis, and you have time on x-axis. You want to find acceleration. So to find the acceleration, what you have to do, you have to draw a tangent. How to draw a tangent? Example, if I say find acceleration at time is equals to 2 seconds. So we want to find acceleration when time is equals to 2 seconds. So first what we do, we will mark a point where time is equals to 2 seconds. So we'll first mark that point on the line where the time is equals to 2 seconds. So this is a point where time is equals to 2 seconds. Then what we do, we draw a line which we call a tangent. And what is a tangent? Tangent is a line which only touch or pass through one point. So we try to draw a line which is only passing through that point, and the length of the tangent is up to you. You can draw a shorter tangent, you can draw a longer tangent, but it's better you draw a longer tangent. It will give more accurate result. And using a ruler, you have to draw this line. So you place your scale or a ruler and draw the line, and that line should only touch the point. And that this black line, what we call this, we call that as a tangent. So first what we did, for a non-linear graph or for a curves, what we have to do, we have to draw a tangent. Then how we'll use tangent to calculate acceleration, that's the second part. But the first thing is, you can draw tangent not anywhere, because in the question I specify that you want acceleration when time is equals to 2 seconds. So when acceleration as time is equals to 2 seconds, so what you have to do, first you have to mark a point where time is equals to 2 seconds. So first we identify that this is a point where time is equals to 2 seconds. And now from this point we have to draw a line through this point which is touching only this point, and that will be a tangent. I cannot draw tangent like this. Why I cannot draw tangent like this? Because tangent should not cross the graph line, it should only touch the point. So even I cannot draw tangent from the bottom because it is crossing the line. The tangent only touch the point. So when I draw, it will only touch that point, specific point. So this is a tangent. Is it clear how to draw a tangent? Then using a tangent, how you can find the acceleration? So using a tangent, how you can find the acceleration? Acceleration is equals to change in the velocity. The formula, what you have to do, you have to find a gradient of a tangent. To get acceleration. And what is the formula for gradient? In mathematics, you will study this formula. That formula for finding a gradient, it is y2 minus y1 divided by x2 minus x1. Just a minute. So the formula for finding the gradient, that is y2 minus y1 divided by x2 minus x1. This is a formula to calculate a gradient. But what is y1, what is y2, what is x2 and x1? So the first point of a tangent, this bottom point, that's called y1. So first point on y-axis, that's called y1. And same thing, the first point of a tangent on x-axis, when we draw this line, the point where it touches the x-axis, that is called x1. Same way, the top point, the highest point on y-axis, the final point on y-axis, that's called y2. And the final point on x-axis is called x2. So what are the values for y1 and y2? Like as you can see, y1 is approximately 18, y2 is, you can draw a bigger line, you can draw a shorter line, it won't make difference to the final answer. As answer slightly change but not too much difference. So length of a tangent does not affect your final answer. So example, y2 is equals to 32, then x1 is equals to 1 and x2 is equals to 3. So when we calculate the gradient here, which is y2 minus y1 over x2 minus x1, so y2 is equals to 32 minus y1 is equals to 18 divided by x2 is equals to 3 and x1 is equals to 1. So 32 minus 18, that's equal to 14, and 3 minus 2 equal 3 minus 1, that's equal to 2. So 14 divided by 2, that's equal to 7 meter per second square. So the acceleration of this object is 7 meter per second square when time is equals to 2 seconds. Is it clear the concept? Whenever you have a non-linear graph, first what you have to do, you have to draw a tangent. And after drawing a tangent, length of the tangent, like this length which I drew here, this length can be any number. It's up to you. But if you draw a longer tangent, you will get more accurate answer as compared to a shorter tangent. Another example for a non-linear graph. Yes, Abdullah Khan. Any question? If the tangent is smaller, what if we draw basically what happened for these type of questions, they give you a range of answer in a marking scheme or in an answer key. You will find that the range of acceleration is given, like example, from 7.3 meter per second to 7.6 meter per second. So these type of answer, these type of question, they normally give you a range. And when you're drawing a tangent, you can draw a shorter tangent, but for more accurate result, you should draw a longer tangent. Like example, if this was a graph for a speed time graph, and a similar graph was there, say a similar graph, and you want to find, like two students solve the same question, student A and student B, 1, 2 and 3, example 1, 2 and 3. So we are finding acceleration. at time is equals to 2 seconds. So if you are finding acceleration when time is equals to 2 seconds, so what I have to do? I have to draw, I have to first mark a point where time is equals to 2. Now student A, draw the tangent in this manner, and student B drew a longer tangent. So student A answer, when he calculate example, he is getting an answer that acceleration is coming out 7.3 meter per second square, and student B is getting the answer 7.45 meter per second square. So both are getting the answer in the range, because in the marking scheme for these type of question they give you the range. So both of them are getting the right answer, because 7.3 to 7.6 is right. So student A is getting the right answer, student B is also getting the right answer. But which one is more accurate? Student B answer is more accurate. Why? Because when you draw a longer tangent, you cover a greater space, that increases the accuracy of the answer. So answer is right for both student A and B, but accuracy of student B will be greater as compared to student A. Is it clear? So it's not about right or wrong. Answer will be correct even you draw a shorter tangent, but more accurate answer when you draw a longer one. Is it clear, this point? So these type of questions, always you will find a range of answer that they provide. So we have another example like speed time graph. And this was a line. Yes, Abdullah, Sarfraz.
Sir, you said the student B's answer is good. So what should be like a good line or a good length that should we draw of the
5
tangent?
centimeter. Length of a
Okay.
tangent 5 centimeter is best. Like you will get more accurate result when you're drawing it 5 centimeter. Okay, another question. So 1, 2, 3, 4, 5, 6, and then we have 10, 20, 30, 40, and 50. Then the question is find acceleration when time or at time 4 seconds. So we are finding acceleration when time is equals to 4 seconds. So first what we do, we will mark a point on the graph line to show where time is equals to 4. So first we mark a point where time is equals to 4. Then what we have to do, we have to draw a tangent. Now I'm drawing 4 different tangents and one of them will be right, and I'm asking which one is correct. So student, like student A, this is a tangent by student A. Student B, draw this tangent. Then student C, this is a tangent drawn by student C, and another student D, draw the tangent. So which student draw the tangent correctly? A, B, C, or D? So tangent which is drawn by student C is correct because that is passing through that point only and it should not cross or cut the graph line. So student C tangent is correct. So student C tangent is correct. Now, so when student C draw this tangent, it should touch that point only for accuracy. Now what we do, again we find a gradient, and that gradient which is y2 minus y1 over x2 minus x1 is equals to drawing a tangent upper or beneath depending on the graph line. As you can see the previous graph, I drew the tangent up at the top. Why? Because if I draw from the bottom, it will cut. So if a graph line slope is decreasing, you will draw the tangent at the top. If it is slope is increasing, you will draw the tangent at the bottom. So position of the tangent changes with a graph line. So in this case, we should draw the tangent beneath or below the graph line so that it will not touch the or cross the graph line. Now we have the formula y2 minus y1 over x2 minus x1. So we'll use the values. The first point, that is called y1. On y-axis, that point is called y1. I'm not writing the full scale but in exam you will have the full scale. The first point on x-axis is called x1. The second point on y-axis of a tangent, that's called y2. And the second point on x-axis is called x2. Then using a graph, you will work out the values. Like example, say y1 is at, y2 is at 40, y1 is at 9, x1 is like 2.9, and x2 is like 5.2. So when you substitute the values y2 minus y1, so it will be 40 minus 9 divided by 5.2 minus 2.9. So 40 minus 9, 31, and 5.2 minus 2.9, that's equal to 2.3. So this will be 2.3, and 31 divided by 2.3, that's equal to 13.47, or I can write 13.5. I can convert this, round off to 13.5 meter per second square. So that is the acceleration of this object when time is equals to 4 seconds. Is it clear how to calculate acceleration for a non-linear graph? Then another thing which we can calculate, so what we do simply, I'll repeat Simon. Example, we have a graph or two different graphs are there, but this is for non-linear graph. For linear graph, we can directly use a formula, we don't have to use a gradient. But for non-linear graph, non-linear means when the graphs are curved. So you have speed time graph, here also speed time graph. The slope is increasing here and the slope is decreasing. So where I should draw a tangent when the slope is increasing? We will draw the tangent beneath the or below the graph line. And when slope is decreasing, we will draw the tangent above the graph line. So when I draw the tangent at a specific point will be there because the acceleration is continuously changing. So it can be any point. They will ask, they will specify at what point you want the acceleration. So example, if I say like this is the time axis 1, 2, 3, 4, and here also 1, 2, 3, 4. So if a question is acceleration when time is equals to 2 for both graphs. So what we will do, we will mark a point where time is equals to 2 and we will draw a tangent below the graph line. If it is written decelerate, it cannot be written deceleration here as you can clearly see the speed is increasing. So when speed is increasing, it is not decelerating, it is always accelerating. When time is equals to 2, again what you will do, you will draw a tangent when time is equals to 2 and work out the values. How you work out the value? The first value on the y-axis is called y1. So this value on y-axis is called y1. The second value on y-axis is called y2. First value on x-axis x1 and x2. So this one is y2, y1, x1, x2. Same thing if you want the acceleration. So the first value starting point of a tangent, that's called y1. The second point is y2, x1, x2, and you will use the formula of gradient, which is y2 minus y1 divided by x2 minus x1, and this is for the non-linear graphs. Non-linear means that the graph, it's a curve, it's not a straight line. If it is a straight line, you will simply use a formula and calculate the acceleration. So you can see this example, they give you the question is, it's a curved line. The curved line on the graph shows the motion of the car. So a car is moving and this is a speed time graph. They're mentioning what is the acceleration of a car when time is equals to 4 seconds. And they already drew the tangent for you. You can clearly see when time is equals to 4 seconds. So this is a line which they drew. So you don't have to draw a tangent here. They already draw the tangent for you. So this is a tangent. The question is, what is the acceleration? Can you work out the acceleration from these results? What is the acceleration? Acceleration is equals to gradient, and gradient is y2 minus y1 divided by x2 minus x1. Yeah, what is the right answer here? Your answer should be visible to everyone. You can use the screen annotation to state the answer. What could be the right answer for this? So when you use the formula, it's y2 minus y1 over x2 minus x1. So the first point, as I mentioned, the first point on y-axis is called y1. So what is y1 here? What is the value of y1 according to this? So y1 is equals to 3.0, or you can say 3. What about y2? So y2 is 12. Then when we check the x-axis, the first point on x-axis, that's called x1. So what is the value of x1? That's 2. And what about value of x2? The second point when you find, that's equal to 5. So half of this question is already done for you. You just have to work out the gradient, and that will be the acceleration. Then we work out the gradient. The formula for gradient is y2 minus y1. So 12 minus 3 divided by x2 minus x1. So 5 minus 2. So 12 minus 3, that's equal to 9. And that 5 minus 2 is 3. So 9 divided by 3, that's equal to 3 meter per second square. So D will be the right answer for this question. Is it clear? This example from a speed time graph, a non-linear graph is there, a curve was there, and you work out the acceleration from this curve. So the correct answer is D. Another similar question. The graph shows how the speed of a car varies or changes during the journey. What is the value of acceleration of a car from 6 seconds to 10 seconds? So how we can work out from 6 seconds to 10 seconds? Because it's a straight line, so when it's a straight line, we'll use a formula which is v minus u over t, where v is the final speed. So what is the final speed here? 15. U is the starting speed. So at time is equals to 6 seconds. What was the starting speed? That is equals to 10. And what about the time interval from 6 second to 10 second? That is, the time interval is equals to 4 seconds. So acceleration is a change in the velocity. So 15 minus 10 divided by time interval, which is 4. So it will be 5 divided by 4. And 5 divided by 4 is 1.25 meter per second square. So C will be the right answer for this question. So it's a straight line graph. It's a straight line graph. That's why we use a formula. But in the previous example, it was a curve. That is why we use the tangent or a gradient. So there's a difference way we use to calculate the acceleration. For a curve, it's a gradient method, and for a straight line, we always use a formula. So I'll share another link and continue the discussion of speed time graph.